So we're dealing with distance and midpoint formula 1.3 today, making sure that we understand some information about lines will help us out, but definitely to be able to find the slope is something we will work on quite a bit this year. And we won't use it tons in the distance and midpoint formula, but to find the slope, remember slope means what? All the way back to algebra a whole year ago. What over what is slope? Yeah. Rise over run. Okay, another way to think of it is change in y over change in x, which is that delta symbol there. It's like a little triangle. Delta y, delta x. So in this one, pretty easy. If we're looking at the slope of the ladder, we're rising how far? 40. This is 40 because that's 40, and we're running 20. So rise is 40, run is 20, and 40 over 20 is 2. Slope of 2. Okay? And number 2, how much do we rise from here to there? Go up 1 and over 2. So once again, this one this one isn't a slope of 2 over 1. It's 1 over 2. What's the letter we use for slope? M. Right. Okay, change in y over change in x. Anyone remember the slope formula? We subtract some things. Sam? Good. So it's y2 minus y1 over x2 minus x1. Okay, so the change in y over change in x. So like on this one, when we're doing change in y, that's from here to here, we changed 1 unit. And from here to here, change in x, we changed 2 units. Well, if we're not plotting the points, we'd have to say, well, that's x1, and that's y1, and that's x2, and that's y2. Okay, y2 is 2, y1 is negative 4, x2 is 1, and x1 is 4. Notice I use these, I put parentheses as like little seats on a ride there. 2 minus negative 4 is 6, and 1 minus 4 is negative 3, which is negative 2. Once again, change in y over change in x. So what are we changing here? What do we change right here? 2. What do we change here? 3. What do we change here? 1. So it's not constant. So let's see right here. What's the change in x? Yeah, 4. So when I went up 2 in y, I went up 4 in x. So this would be 2 over 4. Let's see if this gives us the same fraction. What do I change here? Plus 6. So I went up 3, I went up 6. 3 6 same as 2 4s? Yep, that's good. What better this be? Better be 2. So give us 1 over 2, which it is. Good. They all equal 1/2. Quick review of slope. All right. Any questions? Okay. Hey, today our learning goals are up here on the top of the page. So why don't you copy those down real quick. Well, you don't have to copy them down. It's up to you. It's a nice checkoff sheet, but there's your title. We're covering section 1.3 using the distance and midpoint formula. It's on page 19 through 26. Learning goals, find the links, segment links using midpoints and segment bisectors. Use the midpoint formula and use the distance formula. My kids are in pre-calculus, and they both, like really quick, reviewed this the other day. In fact, my son had a quiz on it on Friday. I think my daughter has a quiz on it today. So distance and midpoint formula doesn't go away. Probably on your first quiz of pre-calculus, which in 2 years from now. Dude, crazy stuff. So get a good understanding of it. All right? Once you finish getting that copy down, I want you to take out Friday's assignment, please. We need our student journals, and you're going to take and work through exploration number 1 and number 2 with your groupies there. Okay?
What page?
Page 12. So it's 1.3, page 12 of your student journal. Page 12 and 13, I think. Explorations 1 and 2. Okay? Go ahead and work with your groupie on it. Okay, here we go. So graph AB where points AB are shown. All right. Explain how to bisect AB so that it is divided into two congruent segments. Any ideas? No ideas? Alex?
So you just basically find the center of the line and then you just split it in half.
Okay, find the center of the line. How many of you tried to find the center of the line? How'd you do that? The slope? So how'd you use the slope? Okay, so you did rise over 1. So you said I rise, how much we rise? 6. And we run how much? 8. And so how did you do that? Use that to find the center. Good, that's perfect, man. 1, 2, 3, and 4. Good. So rise 3, run 4, and that gives you the center. Anyone follow that same idea? Danica, question? How'd you do it? Okay, so you just said, hey, this is the only point it crosses perfectly, so I think it's that one. All right. Anyone else? So, yeah. Okay, sounds like it's kind of what Danica did there too. Yeah. So what are our coordinates there? -1, 1. Okay. Compare the x-coordinate AB and M. Compare the y-coordinates of AB and M. How are the coordinates of the midpoint related to the coordinates of AB? Let's take a look at that. Let's say I have A. A is at 3, 4. Point B is at 5, -2. Or -5, -2. What if I were to add those coordinates up? Say I said 3 plus -5. What do I get? -2. And I add the y values up. What's 4 plus -2? That's 2. How do these coordinates relate to those coordinates? It's half of them, yeah. If I take this and then I divide it by 2 or multiply it by a half, I get -1, 1. And really, that's kind of what you've done here. Okay, you've used what's called the midpoint formula. Okay, the midpoint formula just says if I take my x-coordinates, if I say I want to find the midpoint is my x-coordinates, x2 plus x1, why x2? Because we always start with 2. x2 plus x1 over 2, and y2 plus y1 over 2. You're finding the average of two coordinates. You're adding two things and dividing by 2. You're finding the average. So if I add -5 to 3, I get 8. Or excuse me, I get -2, and then divided by 2, I get -1. If I add -2 to 4, I get 2, and divided by 2, I get 1, which happens to be my midpoint. That's called the midpoint formula. How many remember that from algebra? Holy moly. No one remembers it? Is Patrick here today? Where's Patrick at? Patrick, do you remember? Unbelievable. Oh, no, Danica. Okay, a few of you remember it. That's good. All right. There's also this other thing called the distance formula. If I was trying on exploration 2, and I know most of you didn't get here, if I wanted to find the distance of this line, I could kind of go the same route, but I'd have to use what's called the Pythagorean theorem. Now, how do you remember the Pythagorean theorem? Now notice I made my triangle different this time. I could have went the other way. I could have still went up this way if I wanted, and over. Okay? But tell your neighbor what the Pythagorean theorem is. Good. A squared plus B squared equals C squared. So here's A, here's B, here's C. Does it matter which one's A and B? Nope. So what's this length again? 6. What's this length? 8. Okay, so if I take A squared and add it to B squared, I should get C squared. That is the Pythagorean theorem. So I'm kind of doing that right there. Okay, in this case, that would be 6 squared, or 36. I'm going to write that right there, just so I remember it goes with that side. And b squared, or 8 squared, which is 64. I'm going to write that there and circle it. What's 36 plus 64? 100. And that's this side squared. Good, c equals 10. Okay, that means this equals 10. All right. Did that actually equal 10 when you guys measured it? No? That's ridiculous. What kind of assignment is this, man? Oh, I don't have, this isn't centimeter graph paper. Is your centimeter graph paper? Well, then this ruler isn't helping us. Unbelievable. All right, well, half a centimeter? So then it should equal 5, right? So when it says use centimeter graph paper and they don't give you centimeter graph paper, that's not helpful. So we'll cross out the centimeter. All right, so measuring is not going to help us out there. But if you actually measured this side with your ruler and squared it, and then measured this side and squared it, it should equal the square of that side. Okay? All right. So the distance formula, by the way, we use the Pythagorean theorem to get there, but the distance formula is this. For those of you who don't remember, it's d equals x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Square root of all that stuff. Okay, I forgot the word square root, didn't I? Yeah, it's pretty complicated, but notice the similarities between a squared, b squared, c squared. If I got rid of this squared here and brought it over to this side, that would put a square root symbol there. So really, you're just saying, like, this is a squared, this is b squared, and this over here is c squared. Everyone understand how we're getting that? So like if this is, well, we won't go through that. I think we're okay there. Okay, I want to try some problems after we take a look at some of your notes here. For those of you that aren't familiar with the workbook yet, just so note the next page actually shows you all those notes. It gives you some places to list notes. I want to hit on a few terms. One's called a bisector. The word bisector means it cuts something in half. If something gets cut in half, it makes equal parts, and we show that by putting that little marking right there. So the bisector of AB is M, meaning AM is congruent to MB. They're bisectors. Okay? A midpoint is where that bisector is. All right. Let's try a couple problems real quick. I'm going to spend a couple minutes here. I want you to identify the segment bisector of PQ, then find PQ so you can take notes. These are this is the monitor progress out of your textbook. So like remember the examples right under each example in the text, there's a monitor progress. These are them. So this is number 1. If you wanted to go home and look at the online video about this, you could. They would walk you through it just like I am. But go ahead and answer those 2 questions. You get about 1 minute with your groupies. Okay, here we go. Identify the segment bisector of PQ. What is the segment bisector of PQ? M is. Good. What is the length of PQ? Yeah, if we have 1.78 here, and this is a bisector, and it shows that that is congruent to that, that means this is 1.78, which gives us 3, well, actually gives us 1.78 plus 1.78, or 1 and 7/8, excuse me, plus 1 and 7/8, which is 2 and 14/18, or 2 and 14/8. 2, all right. Which is what? 3 and 6/8, yeah. We have to take 8/8 out of that, which is actually what? 3 and 3/4, or 3.75. Good. Where? Right here? It's a 4, dude. Come on. My bad. No, I know. You guys should use a pencil. Here, I'll do that on this one. What's the segment bisector here? M. So that makes this 2 and 2/7 as well, right? Exact same. That's 4 and 4/7. Very good. Questions? Nito Burrito, we're going to make it progressively more difficult. Ready? You're welcome. Dude, here we go. Number 3. Give it a go. Work with your groupies. Okay, here we go. Identify the segment bisector of PQ, then find MQ. What is the segment bisector? M is. Actually, or line L, right? Line L is your actual segment bisector. Point M is where it bisects at. Okay? If we want to find MQ, we're going to have to say, we know this is equal to that. We know 5x minus 3 equals 11 minus 2x. Now, one of the disturbing things I had this morning, as amazed and proud of you as I was about you guys coming in for help and the questions I got this weekend, many of you forgot how to solve basic equations. And I'm not just talking like one of you. I'm talking about 5 or 6 of you that asked me questions. I'm glad you asked me. Okay? Collect variables on the same side. We got to move this over to there. That means we add 2x. Okay? So 7x minus 3 equals 11. And then we add 3 to both sides. So we get 7x equals 14. And then divide by 7, x equals 2. Did we find MQ? No, we found x. How do we find MQ? Plug it in right here. 11 minus 2 times 2, or 11 minus 4, which is 7. All right. That is our solution. Any questions there? For the sake of time, I'm not going through 4. We don't have the time there today. Sorry. But you could always check that out online if you want. All right. Here's what I want you to do. I want you to use the distance and midpoint formula. I want you to find the midpoints on number 5 there. Find the midpoint. Okay. Hey, remember midpoint's the easy one. We add our x's. So x1 plus x2. So in this case we get 1 plus 7 and divide by 2. And then we add our y's. It doesn't really matter the order we add them in. They always say y2 plus y1, but when you add, it doesn't matter order. So that's 8 plus 2, or 2 plus 8, divided by 2. So we end up with a coordinate of 4 over, or 4 comma 5. Midpoint. Now remember, if you didn't know that, you could always plot the points and look for the middle, but midpoint formula is the easy one. Okay? Try number 7. Be careful on 7. It has a different question on it. All right. Here we go. So if this is M, or excuse me, that point's M, this one is T, this one is U. Let's say we have that. T is at 1, 1. M is at 2, 4. How far do we go from T to M? Yeah, sorry about that. Yeah. How far do we go from here to here? From 1 to 2. How much do we, how far from 1 to 2? Yeah, we add 1. So how far are we going to have to go from here to x here? Yeah, we're going to have to add 1. So this is going to be 3. How far from 1 to 4? 3. So how far from here to here? 3. What's that make this? 7. That's the easy way to show that. Now you could actually throw it into the formula, but that works out. 3, 7. Okay, so ladies and gentlemen, you have the distance formula. You're going to have to use the distance formula today. Make sure you can write it as the Pythagorean theorem. Use it that way if you want. Or you can use the actual formula. That's up to you. All right? Just like we did in our exploration. Okay, so let me go ahead. Your assignment today, let me get you that. Do this. Some of them are pretty easy. Some of them are a little more difficult. Get you that, and off you go.